Hi, in this video we discuss LeetCode problem 1552 magnetic force between two balls. Okay, so what is the problem statement? Problem statement: in the universe Earth C137, Rick discovered a special form of magnetic force between two balls. If they are put in its new invented basket, so what is the invention that Rick has in empty baskets? The ith basket is at position I. Morty has M balls and needs to distribute the balls into the basket such that the minimum magnetic force between any two balls is maximum. Okay. So Rick stated that magnetic force between two different balls at position X and Y is absolute difference between X minus Y. Given the integer array position and the integer M, return the required force. Okay. So they will actually have some basket. Okay, and also they will provide the position of this. Let's take the example of this. So they are actually how many baskets are there? 1, 2, 3, 4, 5. 5 baskets are there, and they also provide the position also, like, right? So first basket is present at 1. Okay, so first basket is present at 1. 2, 3, 4, 5, 6, 7, 8, 9. Suppose so. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now first basket is present at 1. Here actually one basket is present. Okay. Next basket is present at 2. Next basket is present at 3. Then it's 4. Then it's 7. Right. 5 baskets are there. 1, 2, 3, 4, 5. And also they have mentioned that I have to place 3 balls out of this 5 basket, right? So M is equal to 3. So what is the problem? Problem is that I have to place 3 balls out of this 5 basket within the 5 basket, and how actually I have to find out what is the minimum force I have to record. Like they have mentioned that like the minimum force needed for any combination, that the minimum magnetic force between any two ball is maximum. Okay, suppose first I placed one ball here, one ball suppose here, and one ball here. 3 ball I placed in 3 basket, 1, 4, and 7. Okay, so what is the distance between these two? These two is 3. 4 minus 1 is equal to 3. What is the distance between these two? These two is equal to is 4 minus 7 is equal to 3. Again 3. What is the distance between these two? This is actually 7 minus 1. This is actually 6. So what is the minimum gap or minimum magnetic force? 3. Right. So for this combination, my required force will be 3. And I have to maximize this force. Like they mentioned that, right? That I have to place M balls within all those provided basket such that the minimum magnetic force between any two balls is maximum. So minimum magnetic force between any two balls, that I have to actually maximize, right? So suppose next combination is suppose here. Next combination is suppose this is actually 1. This is actually second ball. This is actually third ball. Suppose. So again, what is the distance between these two? These two, it will be 2 minus 1. It will be 1. What is the these two? This distance is 7 minus 2. This will be 5. So what is the minimum? Minimum is 2. So answer will be 2. Got it? So in this actually I can actually what actually I can do actually, like brute force approach. What will be the brute force approach? Like I will check that what is the maximum force I can actually try. Like what is the maximum force actually I can try? Like like in this way, like leftmost basket is present at the position 1 and rightmost basket is present at position 10. So if I placed one ball here, and one ball here. So what is the actually distance? 10 minus 1, it will be actually 9. This actually this actually give the maximum magnetic force, right? And I have to actually maximize this. Now what actually I will try? I will try that I will place one ball in the leftmost position and next ball in the rightmost position. Again, if it is m is equal to 2, for this m is equal to 2, suppose m is equal to 3, I have to place in such a way that in between the distance actually maximize. Like here it will be try to x and it will be y. I have to actually maximize x and y both, maximize both x and y. This actually increase our chances to get minimum of distance x and y. It will actually increase, right? So first of all, what I'll actually do, I will actually try with, suppose I will start from maximum value 10 to the power 5. Suppose I will check that is it possible to place m balls with this n baskets at a gap of 10 to the power 5. If it is possible, then this is our answer, and I have to maximize this. So what will I will start from maximum value, like I will start from suppose 100. Here is a 10 to the 5. Then I will check, okay, if it is not possible, then what I should try? I will try 10 to the 5 minus 1. Then it is not possible, again I will try to 10 to the 5 minus 2. Then I will try 10 to the 5 minus 3. In this way, because this actually give us the, whenever it is matched or I found any combination, then this is a possible answer because I am starting from maximum to minimum, right? So in this actually, what will be the time velocity? Like I am iterating from max to min, maximum value to 1. So what will happen actually? Like the range of this will be 10 to the 5 to 1. So suppose this will be take big of n for one for loop to iterate from max to 1, infinity to 1, right? And for check that is there any combination present or not, such that I can place m balls, that actually how can I actually check I can actually place m balls or not? So first of all, I will sort the baskets position. So I will know that if this position is x, this is y, this is z. So x less than y less than z, right? So I will check like how I will check that I can place m balls or not at the gap of g. So first of all, place one ball at the here at the position x. Now I will check if the last ball I position at x is possible, like x plus g, if I add the gap, then y is still greater than this, then actually I can take this, because I can actually place this one ball here, like 10, suppose 20, 30. This is the position of basket. Now our gap is suppose 5. Okay, then first of all, place one ball here, one ball here. Now I will try to place one ball in this position. Okay, how I actually check that is it possible to place or not? How will check? I'll check. Okay, last ball I placed 10. My gap minimum need actually 5. So what is the minimum distance, minimum position I need to place one ball? 15. But what is the current position of the current basket? 20. So actually this is more gap. What we need actually, we need 5, but the gap is 10. So actually I can place one ball here. So I'll place one ball here also. Okay. Then go to next. Next I will check what is the next 30. So I'll check I can place one ball or not. How will you check? Okay, last ball I placed at 20. And what is the gap I need? I need 5. So I need actually 25 minimum position as 25. But what is my current basket position? 30. So I can place one ball also here. So how many balls actually I can place here? 3 ball, right? So I will check how many balls I have to actually place and how many balls is it possible at a gap g, any random g. So if it is m is equal to our possible balls, then this is one gap possible answer. So I will actually return from that point of time. Got it? So this is also take big of m because I will iterate all the baskets positions, right? So if the size of the basket array is m, then I have to, for each gap I will traverse the basket array again. So times it will be n cross m. So this is actually n square almost. So this actually give us TLE. So let's optimize it more. How actually I can optimize? Binary search actually help us in this situation. How? Like I already know that I can actually go from iterative way, like from maximum distance, maximum gap to then smaller, then smaller to smaller, then minimum, right? So in binary search, what actually we actually do? Like I will randomly I will get any mid value, then I will check that is it possible with this mid gap as gap. Then it is possible. Then this is our answer, right? Else what will happen? This is not possible. Then we have to decrease the gap, because if this current gap is not possible, suppose with gap 10 is not possible, then it is possible to place m balls with 15, not possible, because within 10 actually not possible. Then how it is possible to with 15, right? So what I will do, I will place the mid, I will get one mid, I will check it is possible to place all the m balls within the basket at a distance of mid. If it is possible, then try to increase the, this is one possible answer. And also I have to increase the maximum gap. So actually I will try to search the next. What will be next? Next will be mid, L is equal to mid plus 1. Else what will happen? Like this is not possible at the current gap, then actually I have to decrease the gap, right? So that time what will happen? R will be decreased by, will be placed by mid minus 1. Got it? In this way actually. So in this way actually, how actually optimize this? So in binary search, like in our search space actually, it actually smaller. Like how, what will time is this? So it will be log n cross m. M will be again same, because this actually I have to search again each. I have to traverse the basket array, and I have to check what is the position previously ball I have placed, and what is the current position of the basket. Can I place the current ball here or not? This actually I have to check. So this will again m, but here actually I have actually optimized this. So this will be m log m. Got it? So let's go to the code. So first of all, I have sorted the basket array. So this actually give us to place the ball in a sorted order. Now, what is the search space? Search space means what is the maximum gap it is possible. What is maximum? What is the leftmost position of the basket? Position dot front, and what is the rightmost position of the ball? This actually give the maximum gap. So this is L will be 0 and R will be position dot back minus position dot front. Basket position of 0 and n minus 1. This actually give the maximum gap. So I will run the binary search here, like while L less than R, I will get one mid, and I will check. I will call the count one helper function. This actually pass the basket array and the mid. Mid means here it will be gap. Like in particular gap I have to place. Right. So if it is possible, then what will happen? This is one answer. So L will be mid. Else what will happen? This is not possible. So I have to actually decrease the gap. So that time R will be mid minus 1. And at the end, return the L. So here actually I have called one helper function. So what is the helper function? Helper function, I will get the basket positions and I will give the gap. So what I'll actually try, like answer will be initially 1, because I can always place one ball at the leftmost position, in this position 0 index, and I will try to place a new ball from here actually. So current will be position of 0. This is actually last ball I have placed, and I am iterating the basket array from I is equal to 1, and I less than position dot size I plus plus. And what will actually search? Position I minus car greater than equals to D or not. Position of means current basket position, like this is a position, and what is the last position I have placed? Is this greater than equals to gap? Then actually I can actually place one ball in this current basket. that's actually I have checked here. Position, current position of the basket, and the last ball where I placed the one ball, if greater than equals to the gap where I need. So that time actually I can place one ball here. So that's why I increasing the count of answer, and also set the last ball, because I have actually placed one ball in the current basket. So that's why the last ball for the next future it will be current will be position dot I, current basket position. Okay, and at the end return answer. This actually count how many balls I can placed width of gap G. G means here mid D. Okay, if it is greater than equals to M, then actually this is one possible answer, right? M is going to suppose 3, but I can place 10 balls. So this is actually one possible answer, right? Because I can actually place 10 balls, then obviously I can place 3 balls also. That's why I will check if it is greater than equals to M, then one possible answer, then check. Okay. So this is actually I am traversing the basket array again every time, each time. So this will be M, and this here actually while loop will run in log n time. So time will be M log n. Got it, right? Thank you.